Hi, my name is Morgan Thomas Price, and in this video I'm going to be talking about my Programming Audio-Visual Experience project. Now before I begin, I'm going to just explain what my project is and what it does. For the output of my project, I'm using a simple DC motor with a fan module attached to it. What I'm controlling is the speed that the motor turns. My P5 sketch gives the users 10 points of customization. Each point is a second in the pattern. Once the pattern is complete and uploaded, the DC motor plays the pattern using the Arduino microcontroller. One thing I really like about this project is once you've uploaded the pattern, you can physically look through the stages of the pattern on the screen and see it represented on the DC motor in real time. The way my P5 works is I have 10 rotating fan-shaped objects. You can select and change the speed of them, and once you are happy, send it to the board. This array of values is written onto the EEPROM and then played on the motor. The way I have done this is by setting up a speed array, which the selector is able to select every fan, and a slider which can change the speed of each one. I have also set up for all the serial communication and made it so the pattern gets uploaded when you press a button on the screen instead of a key press. My JSON is saved as a file called myPattern, which will be used a lot in my Arduino code. I have also set up several print commands, so it will tell me when it is connected to the server, a list of serial ports, if the serial port is open, and if it is closed. I'm now going to talk a little bit about my Arduino code. You can see at the top I have included two libraries, EEPROM, which acts like a memory on the board, so when you send a JSON, the EEPROM will remember it and play it when connected to a power source. The Arduino JSON unpacks the JSON and then sends it to the EEPROM so it is ready to be played. To begin, I have to initialize my config to include an array with the same amount of values as my speed array in P5. I have called this array fan speed, and I've called my config my pattern, which you'll remember is the name of my JSON that my P5 sends. We immediately set the play mode to false, so it won't play anything straight away. I then set up my motor pin output to be 3, which just tells the Arduino to send the message out of pin 3 on my Arduino board. The buff size just tells the board how many bytes to prepare to receive. I'm using an Arduino Uno which doesn't have an insane amount of storage, but because I'm just using one array, the size doesn't need to be huge. I have chosen this value because it gives me all the memory I need. Next we have the capacity. Here I've stated my array size is 10, so the board knows it should be receiving 10 values, and it should be getting just one set of values, and these values don't change on their own. Next we have the setup. I have initialized motor pin as an output and set the serial begin to 9600, which is the recommended output. Then it is set up so whenever the board starts it says fan speed from JSON, waiting for JSON. In the void loop we start by initializing an end of command message and a string terminator. We also tell it to pass the JSON, which basically means telling it to do something about it. Then we set up a message, so if there is no room for the message, it will tell us in the serial monitor. This message will be read as lost byte. If it does read it properly, we have set up the board to wait 10,000 milliseconds, which is 10 seconds, for a config, and then tell it to play if it doesn't receive one. It will play the config it has already saved, if it has one saved already. In the past JSON, it is set up to recognize when it has received a JSON string and deserialize it. If it fails, it will write a message saying it has failed, and it will also write one if it is succeeded. Now you tell the code what JSON to retrieve. So it knows to look for a document called myPattern, and it will print the length. We then need to express the config so it knows my new message needs to be added to the fan speed in my pattern config in my Arduino code. Once it has all this info, it writes the new message onto the config and turns the play mode to true. For the EEPROM, it needs to grab my pattern from my JSON, starting from its first value, and it knows to write it on the EEPROM and read it. I then set up a simple play function which tells it to start on step 1 and that the maximum step is 10, and that it needs to read them in order to send the information to the motor pin. The delay tells it to play every step for 1 second. And that is my Arduino code. I am now going to walk through the workflow on how to get all the information properly transferred onto the board. Getting the information from the P5 onto the Arduino board is a little bit difficult, as if you do one thing out of order, it will not work. The first step is to upload the code onto the Arduino, ensuring that your serial port is closed. Once done, you should see the message show up in your serial monitor. Once you do that, open P5 serial port and open serial connection. Then go into P5, open the sketch and play it. You should see a message saying that the server is open. If you press the restart button on your Arduino board, you should see the messages you saw in your serial monitor on the Arduino IDE show up in your P5 console. Then you must make a pattern, press the restart button on the Arduino again, and press save to EEPROM. Then the fan should immediately start running your pattern. And that is how my project works. Thank you for watching.